Okay, howdy y'all. We're back. So continuing on our discussion about what makes a good representation, and I'm gonna, first of all, we need to make sure that the properties of the represented world are represented, and then what's irrelevant, we want to abstract them out. We don't want to add additional data, additional features if they're not going to support the intended cognitive work because it adds confusion, because it adds potentially additional cognitive work steps, that clutter up our cognitive task analysis, right? Okay, so this is a good case study that I certainly like to bring up here in the context of we need representations that can both help us problem solve reflective artifacts, reflective representations, and those that can be used to convey messages to decision makers that are really important. So probably most of you know, the basics of this. I know we read a little bit about it in the first half of the course, but the Challenger accident, the Challenger explosion, the essence of this accident was that the launch happened at a very low atmospheric temperature. It was very cold the day of the launch, and they had never launched in temperatures that cold before. And engineers, so what you see here on the side, this is called a solid rocket motor or a solid rocket booster, SRM or SRB. There are two of them, and those are like the initial, hey, liquid, what is it, like liquid oxygen, I think, or something. It's extremely liquid fuel, NASA fuel, jet fuel. And there are O-rings sealing the joints in these solid rocket boosters. And under cold temperatures, those O-rings failed. And when the O-rings failed, fuel leaked out, it ignited, it then, the entire system exploded. And so, yes, now this wasn't like, oh wow, we were surprised. We like engineers knew this, but think about. I know that we talked a little bit in class, and you read a little bit about it. But a lot of the decision to launch, the pressures that drove that came from President Ronald Reagan. And President Reagan, on the evening of the launch, was giving his annual State of the Union address. And a big part of his message was, look at our space exploration program, and we just sent this first teacher into space, and isn't that cool? And it is a cool thing to be able to say. But when the president says, no, we really should launch today because I have this big speech, but the engineers at the other end of the chain say, we really should not launch today because it's cold and we know that this is going to be a major safety risk. Well, how do those engineers down at the bottom of the chain, the ones who really understand the nature of this problem, how can they convey that message up through the decision chain that maybe gets all the way to President Reagan? President Reagan's not an engineer, and so you're going to have to convey it in very simple, straightforward, experiential artifact sort of methods. So remember again, that's a big difference between an experiential and a reflective artifact. An experiential one is more about conveying a message and allowing people to basically understand what your point is, but not something where they will then dig in deeply and look for new patterns or new ways to look at a problem. So, Morton Thiokol, that is the name of the contracting agency, Morton Thiokol Inc. You can see down here. And these are the engineers and the engineering firm that developed and managed the solid rocket boosters, the solid rocket motors, SRM here. So they have all of these data. Let's say that they have 24 launches. And so what you're seeing here is solid rocket motor. One goes with launch number one, whatever the Challenger series, launch one. And we have A and B, there's two of them. And you'll note we did keep track of the launch temperature, 66 degrees, 70 degrees, because this is in Florida. It's pretty nice weather most of the time. And then we do have damage. There is a history of O-ring damage, right? When these are recovered from the ocean, right? So there's the launch, and then those fall off, and they're recovered from the ocean, and they may be, I assume, reused to some extent. So they're tracking things like how much damage is at each of these joints. There are a lot of data in this representation. There is not a clear experiential spirit for seeing the relationship between temperature and risk for launch. Okay, so you may note, oh, well, if I look closely enough, I can see 57 degrees, that's kind of cold, and we got something here, and 53, that's kind of cold, and we got some damage here and here. Oh, but here's 70, that's not cold, and we got damage here. So this kind of throws off my pattern recognition. And I'm looking at this and trying to figure out, well, I don't even know what these mean other than this is a representation of O-ring damage and which solid rocket booster and which launch and which and what was the launch temperature. Because I actually need a legend in order to interpret this. Now this is a good example of something I'll talk about later, which is a additive versus substitutive relationship between the representation and the data being represented. Okay, so let me just, I'll get to that, but the concept of damage, of risk, is something you can think about as having more or less risk. You can think of it almost quantitatively. We have zero risk or very low risk. We have a lot of risk. We can lower the risk or raise the risk. And so this is something you should say, these data are quantitative, they are additive, and they need to be able to be conveyed with a representation that is also quantitative or additive. So what you see here, I have no damage to some damage, and actually I'll just tell you that as you go up this list, this means more and more damage to those joints. But if I look at the representation, these are like qualitatively different shadings. And so they convey different qualities in the representation to represent quantities in the cognitive work. Okay? So when I look at this, I don't know without looking at the legend, is this more damage or less damage than this? I need to look at the legend to be able to answer that question. And a good representation would probably not require me to have an additional legend in order to answer all of those sorts of quick cognitive tasks. Which one is more? If it were conveyed with an additive representation, that would be a lot more experiential. But also, okay, so that's a digression. Now imagine this is, I doubt that this is exactly what representation was used to try to convey messages. But at some point we have to go from here's the data we have to, hey, President Reagan, it's a bad idea to launch today because it's that cold. And so this is not going to convey that message. If you said, hey, here's the data we have, and we're showing you the relationship between temperature and damage, and you'd say, well, technically true, but this is going to take me a long time to reflect on. I'm going to have to process a lot of aspects of this representation in order to understand that relationship. Contrast that with this example. And so this comes from Edward Tufte in 1997, said, well, hey, what if we had taken this cognitive work of trying to figure out the relationship between the launch temperature and the risk, and we're the Morton Thiokol engineers, and what if we needed to convey this message strongly and clearly up the decision chain? Wouldn't something like this do a lot better for that? And so what you're seeing here is the same data represented here, exactly the same, but you recognize Tufte said, well, a representation is an abstraction, so there are some aspects of that representation that are unnecessarily included. For example, the shape of each of these boosters. There's a lot of ink that goes on here for not a lot of data. Okay, we talk about the data to ink ratio a little bit later. And so you want to think about, well, is it important that it was launch 6 or launch 7? Or really, I mean, if I'm trying to show the relationship between temperature and damage, I've got a lot more things besides just temperature and damage represented in this figure. And so those are all adding additional reasons to think differently, and not just conveying the straightforward message in an experiential way. So here, if we just say, well, here were the launch temperatures, and we come up with an index of damage, and we just say, okay, well, if we have multiple O-rings that are breached, that's more damage than a single O-ring. And so they come up with a simple metric. So rather than these qualitative descriptions, they say, well, it's just getting worse. And so we have points for damage. And yeah, we still see some noise here, like 75 degrees, and we did have some problems. But the worst problems and the more consistency of problems are happening in the colder temperatures. And this is when we launched Challenger. So very, very cold, much colder than even the coldest launch, which was also the most risky. And so with a representation like this, I would argue that it's a more of an experiential representation that will help people, quickly see that pattern and see the severity of deciding to launch, at this level. All right. So again, that's a Morton Thiokol Challenger example. Didn't I say we'd get to this? Okay, so additive and substitutive representations and additive and substitutive data. Okay, and the simple explanation here is are we talking about moreness or lessness, something with a quantity to it, like more gas or less gas? If that's the case, then the way we represent our data should also convey things with moreness or lessness. They should have a dimension mapped that naturally conveys an order. Okay. Yep. So like here, yeah, the moving gauge, it moves when there's more, and it moves the other way when there's less, and that maps, quantitatively. How many scoops of ice cream do you want? We see this representation growing in height, and so there's moreness when it represents more, like the number of scoops of ice cream is represented by the height of an ice cream representation. So moreness goes with more, additive representations. Substitutive representations, these are appropriate when you have different qualities that don't suggest a moreness or lessness. So a good example would be, for example, like which houses in the state of Texas, what are their favorite football teams? So there isn't a moreness. I mean, as much as we'd like to say, Texas A&M is better than other Texas football teams or whatever, but they're qualitatively different. They're not quantitatively different. And so when we're talking about differences in quality, we want to use substitutive and not additive representations. So, for example, let's say we had a map and we wanted to, draw, all right, each house in this city of College Station, we're going to put a logo on whether they're Texas A&M Aggie fans or TU, University of Texas fans. And we're going to then color each of them maroon or orange. That's a great way to use a qualitative data, Aggies or UT, there's not moreness or lessness here, and represent that with a qualitative dimension of color. So burnt orange and maroon are symbolically associated with these two schools. They're qualitatively different. They're not quantitatively different. Okay, and that's a good mapping. If I instead used the dimension of, let's say, like the darkness of shading, so I could say, UT is light gray and A&M is dark gray, and I don't know, Texas Tech is black, and that would be misleading because we have qualitative data differences and we're representing them with something that is closer to an additive representation. When you go from light to medium to dark gray, there's a continuum there. And so you don't want to use the wrong type of representation for the type of data you're working with. So what's your flavor of ice cream, not the quantity of it, but these are qualitatively different. Oh, and then here's them both, right? So I can get qualitative and quantitative with this representation. All right. So we switch back and forth between these sorts of representations frequently, but there's an interesting parallel when you consider that what I'm pointing at right here, these are Arabic numerals, but what these are well ingrained in our heads to represent quantities. But these symbols are qualitatively different. Okay, so I know I don't want to confuse people too much here. But if I told you I have, parking spot number 47, that is a way of me conveying yes, that you would assume that there are numbered spots below that or above it, but I'm conveying it in a symbolic way, not in a I'm going to go outside and count from the beginning to the 47th spot and I'm going to go there. So if I am representing numerical quantities, but their moreness or lessness is not really considered, then we use these numerals. And often, if we are doing moreness or lessness, representations like this map a little bit better. So, like doing tally counts, right? And so, if I said, "Hey, how many bananas have you sold today?" If I'm a tally man of bananas, then I could, this is a representation that is a little bit easier for me because I'm maybe doing the cognitive work of add one more, add one more, add one more. And if I have to keep erasing my board and writing a new numeral, that's not as effective for my task, which is more quantitative in nature. Yeah, so yeah, you could ask yourself, well, which representation is better for which of these two numbers is larger? And you may think, oh, well, if it's like 1,092 versus 1,045, well, you might say, well, I don't want to try to count this many tallies, but also if you just have them all lined up and they're just the length of my tally, my tally board naturally communicates which one is bigger. I might argue that, the additive representation, the tally marks, is better for that. But if I'm trying to remember something like, well, what were the numbers on that license plate? I'm going to want to use these symbolic representations and not, tallies for the represented values on the license plate, right? Yes, tally me banana, that one. That would be good for additive. Complex calculations like 45.9 divided by 37, whatever, that is done more effectively with our symbols and then the additional, sorts of tricks that we have developed mathematically over human history. Good. Okay, let's pause there, check where we're at. All right, we'll finish this one out here. It might be a little bit longer, but we'll finish this one out. Okay, good. So we come to final points here on Norman's sorts of thoughts on representations and how they contribute towards bridging the gulfs of execution and evaluation. We talked about the making sure that we map appropriately when our data is quantitative or additive. We want to make sure that we relay that through a representation that uses quantitative or additive representation dimensions, and vice versa, right? So for experiential cognition to occur, we really want to rely on those entry-level sorts of intuitive response pattern recognition, things like the tic-tac-toe lineup, for example, looking at the spatial relationships among different countries or different land masses on a map of Earth, versus reflective cognition. We are designed to give people lots of different ways to analyze aspects of a system. So more power for those, but more ways that things could be, errors could emerge. More complex things are more difficult to parse. It takes time and effort and potentially money, to work with them. Good. Now, additive versus substitutive. I have a few more examples. These come from Norman. And so just like what we were referring to with the Norman or the Morton Thiokol legend for the O-ring damage. Here's an example of radon levels. Okay, so this could be a map of the United States, and you'll notice we've got a legend up here, and it's telling me 0 to 10, 10 to 15. This looks suspiciously to me like additive data, and this looks very much to me not like additive representations. Because the way I would answer this, if it was an additive representation, is I would say you shouldn't need a legend. You could just basically have a line that says, for example, we could have. Well, anyway, let me just explain again why this is this unnatural mapping here is problematic. Because if I look at Indiana versus Michigan, And if I can't tell, okay, well, how does Indiana compare in radon levels to Michigan, and how does it compare to Kentucky? I can't really tell, or at least I might assume, but I would be wrong, that the shading here conveys the additive nature of the data. It does not. And so actually, if I see this, oh, Michigan is much less of a problem than Indiana, and Kentucky is also less of a problem. And see, you can see this. This is a particularly difficult mapping here, right? Or I would say challenging, errant, encouraging errors in that mapping. So instead, instead of that, here's a redoing of that same map, but now we have something that's more additive in the representation of these dimensions. And so now I can look at this and say, oh, Indiana's pretty bad, but comparatively, Michigan is less bad, Kentucky is less bad, and Alabama is less bad than Tennessee. And so I can see more readily, without going back to the legend over and over, I can rely on the represented dimensions and the additivity of that dimension to convey the quantitative aspects of the data. Okay, last distinction I like to bring up here are the concepts of digital and analog displays. And this goes for more than just time. You can think of, like aircraft gauges going from the steam gauge times to glass cockpit, and now we've digitized the same data. And think about how each of these are particularly in the realm of additive versus subtractive, here's speedometers, sorts of processing. So if I need to know, for example, exactly what time it is, this digital representation is probably a better one than having to then interpret based on like an analog clock what time it is precisely. I have to do more cognitive steps here versus just reading this off in the digital space. So yeah, substitutive representation is a little bit better there. If I want to know something like, well, how long like in 5 seconds or at exactly 2 o'clock for at a glance comparisons, this might be better. Like, am I late for class or not? And if you know that, well, class starts right here, then that's an easy visual comparison, and it's a moreness or lessness comparison. And so maybe we want more additive representations. Am I going faster or slower than the speed limit? That might be better for this sort of an analog representation versus a digital one, which requires me to do mental math. And I'll just point out here my work with physiological displays. I have appreciated the displays that include both a digital value and an analog trace, because this allows me to see things like the changes over time, and also I can then know, okay, well, my oxygenation level of 97, so it's okay. So if I'm going to do a qualitative check, hey, do they have enough oxygen? Everything's fine. I'm going to get that here. If I want to know, hey, what's the trend over the last few minutes? Is it rising or falling? That's going to be much more effective with an analog representation. That's it, folks. Usability coming in our next vignette. So thanks a lot. I'll hopefully have more stories later today too. Okay, take care.